Look up at the night sky, what do you see? A scattering of tiny twinkling lights. For most of human history, that was all they were. Points of light in a vast, dark canvas. But we are a curious species. We looked up and we wondered, what are those lights? How far away are they? Are we alone in this immense darkness? These questions have echoed through the ages, whispered by campfires and debated in great halls of learning. They are the questions that drive us, that push us to build bigger telescopes and to dream of journeys beyond our own world. The universe is an ocean of unimaginable scale, and our planet Earth is just a tiny island adrift in its cosmic currents. Imagine a machine, a spacecraft unlike any we have ever built. It is not just a passive vessel carrying instruments. It is an autonomous, intelligent explorer. Its mission is not just to visit a single star system, but to explore them all. Think of it as a seed, a technological seed that we plant in the fertile ground of the cosmos. The idea of a self-replicating machine didn't just appear out of thin air. He was a Hungarian-American mathematician, a true polymath whose intellect ranged across physics, computer science, and economics. He imagined a grid of cells like a giant checkerboard by setting up a specific starting pattern of cells to build an identical copy of the original pattern. That connection was forged in the crucible of science and science fiction, where bold new ideas often take flight. Visionary scientists like Freeman Dyson, another brilliant physicist, began to think about the long-term future of humanity and our expansion into the cosmos. These stories, from novels to television shows, brought the concept to a wider audience. They made us ponder the immense potential and the terrifying risks. Through this interplay of serious scientific speculation and imaginative fiction, the von Neumann probe was truly born. So what exactly is this universal constructor that von Neumann envisioned? Imagine you have the ultimate Lego set. This set is so advanced that it contains not only every type of Lego brick imaginable, but also a special robotic arm. The probe would land on an asteroid or a moon and use specialized tools to mine these materials. It would then need a miniature automated factory, a smelter to purify the metals, and a fabricator, perhaps like an advanced three-dimensional printer, to shape those materials into all the necessary components. A self-replicating spacecraft cannot function without is a concept we borrowed from nature itself, but a vast and complex library of digital information. This digital blueprint would be the probe's most precious cargo, containing every schematic, every line of code. Once a von Neumann probe arrives in a target star system, its next critical task is to find a meal. It needs to gather the raw materials required to bring its digital blueprint to life. The cosmos is a giant hardware store, filled with all the necessary elements, but they aren't neatly organized on shelves. With a growing stockpile of raw materials, the probe transitions from miner to manufacturer. This is where the true magic of the Universal Constructor comes into play. The probe must now process the harvested ore and transform it into the high-tech components of its offspring. This requires a miniaturized, fully automated industrial complex. A self-replicating spacecraft cannot function without two final, essential ingredients: a continuous source of power and a high level of artificial intelligence. These are the spark of mechanical life that animates the entire process. Energy is the lifeblood of the probe. It's needed for the long interstellar journey. So what would one of these galactic explorers actually look like? While science fiction often paints pictures of sleek, silver ships, the reality of a von Neumann probe would be dictated by function, not beauty. It wouldn't be a single solid vessel. It would be a modular, adaptable machine, more like a traveling toolkit than a spaceship. Building a copy of yourself from scratch using nothing but asteroid dust and sunlight requires an incredible set of tools. The technology inside a von Neumann probe's factory module would be far beyond anything we can build today. At the forefront would be advanced additive manufacturing or three-dimensional printing on a scale and with a precision we can only dream of. Imagine a printer that can work with a vast menu of materials. A machine this complex cannot be remote controlled from Earth. The light speed delay would make it impossible. The probe must think for itself. This requires a level of artificial intelligence far beyond a simple computer program. The AI is the captain, the chief engineer. Once we solve the immense technological hurdles, we are no longer just sending a single ship into the void. We are initiating a process. We are starting a chain reaction of exploration that could, in time, encompass the entire Milky Way. It replicates, and now there are two. So, what would be the ultimate purpose of all this exploration? It's really about gathering knowledge, but also a librarian, a galactic library of information. They could exchange data and contributing to a growing collective understanding of the galaxy. Beyond mapping stars and planets, the probes would have another more profound mission, the search for life. With millions of robotic explorers surveying billions of worlds, each probe's sensors would be finely tuned to detect biosignatures, the chemical fingerprints that life leaves behind. They would scan alien atmospheres for gases like oxygen and methane. The power to create a machine that can replicate itself across the galaxy is a monumental thought. A single error in the probe's core programming, a tiny flaw in its code known as grey goo. This brings us to one of the most profound and honestly unsettling questions in all of science, the Fermi paradox. The paradox is simple. Our galaxy is ancient and vast, with hundreds of billions of stars. Then where is everybody? Let's dare to dream for a moment. Imagine a future where we have successfully built and launched our first von Neumann probes. We have overcome the immense technical challenges and navigated the treacherous ethical minefields. What would this mean for us, for humanity? The very act of creating such a machine would fundamentally transform our civilization. It would require a level of global cooperation and scientific advancement we have never before achieved. Let's push the dream even further. The core technology of a von Neumann probe is its ability to take raw, unstructured matter and turn it into complex, functional machinery. It is a universal constructor. This is the ultimate promise of the technology that powers these probes. The end of material scarcity. Why would we fight over limited resources on Earth when we have machines that can turn common rock and dirt into anything we could possibly need or desire? It would be the greatest economic revolution in human history. We have journeyed far in this exploration of an idea. We began with a simple question whispered to the night sky and followed it to the very edge of imagination. We have seen how the brilliant mind of John von Neumann planted a theoretical seed, a concept of a machine that could reproduce itself, into a grand vision for exploring our galaxy. In the end, the story of the von Neumann probe is a story about us. It is about our unquenchable thirst for knowledge and our deep-seated need to explore what lies beyond the horizon. For now it remains a concept, a grand what-if on the drawing board of future technology. The challenges are monumental, requiring breakthroughs in artificial intelligence, nanotechnology, and energy that may be centuries away. So the next time you look up at that vast, dark canvas dotted with distant suns, consider the possibility. Imagine a single, human-made seed traveling through that darkness, carrying our hopes and our curiosity. Imagine it arriving in a new system, waking up. Think of that wave of discovery spreading silently across the galaxy, a testament to a species that dared to dream on a cosmic scale. Is this our destiny? Is this the path humanity will ultimately take to leave its mark on the universe? And in the end, it is the questions, not necessarily the answers, that propel us forward on our journey into the cosmos.